Okay, so in our Tuesday session, we had done a quick recap of week one, week two, and week three, right? And after that, we covered relational algebra and relational calculus from week four. So the agenda of this session will be ER model and ER diagram. We will just see some terms related to ER model. We will understand what is an entity, what is a relationship, and what is ER diagram, and in what situations we use them, why we are learning it. Okay, so yeah, let's jump onto it. I hope you are preparing and practicing enough for these relational algebra, tuple relational calculus, and domain relational calculus, right? I even gave you these 15 questions. Had you tried solving them? I hope you did. Okay. Okay. So let's understand what is an ER model. So you see, this ER is coming from two things. E means the entity, and this R means relationship. Wait. Yeah, where we were. Yeah. E is for entity and R is for relationship. And we are going to learn the model of this. So before understanding what is ER model, there are two things that we should discuss. The first thing is what is actually a model. And when we were discussing about relational model, then also I described about it, right? What is a model? Model, as you would already know, in our school time also, whenever there were some vacation time, holiday time, then the teacher used to give us to create some model, right, on a chart paper or like using thermocol or these type of things. So when you say that I created a model of a boat or an aeroplane, what you are actually trying to convey by saying that this is a model? Can someone answer this question? When you say that I created a model of an airplane, this is not actually an airplane, but this is a model of an airplane. So what do you mean by saying that it is a model?
Structure.
Miniature version of what we are actually of the actual representation, sir.
Yeah, so see, we are going to create an aeroplane. So why we are modeling it? What is the reason behind it? The reason behind it, we want to understand a representation of what we are building. Because actually, when you go and try to build an aeroplane, there are several problems that will come if you don't create a model of it. And what are these problems? First of all, there is a cost problem. Building an aeroplane is not a child play. There is a lot of time involved, there's a lot of money involved, and a lot of efforts involved. And those efforts will be put by a lot of people, right? So a lot of manpower is also required. So that's why it's important for us to understand what we are trying to build. We need to have clarity on this first, right? So whenever we want to have a clarity on what we are building, either we talk the theoretical part of it, and that is also important. But when we are building something concrete, then it's always better to create a representation of it that is easy to understand. And for example, when it will be easy to understand when when it is simple, right? And it shows patterns. So these are not the point that are taken from our DBMS slides. This is just about what is our understanding about the model till now. Even in school, when you used to build a model, the reason behind it is to understand what you are building. Because when you create a small representation of it, you can see each and every component. Some components are big, some components are small, but you are easily able to understand, oh, this is how a boat actually looks, right? When you start describing about a boat, then that the upper part looks like this, there is a flag there. When you are just describing it with your words, maybe some people will understand, but some others will face difficulty because they are trying to visualize it in their mind. But when you are giving a representation in front of them, they all can see uh, that where is the upper part, where is the lower part, where is the trajectory, how, like what is the angle at which this trajectory is going at the lower, from lower to the upper part. So you can have this simple representation of a very big thing. So in the same way, when we talk about model in DBMS or something related to application architecture, we mean that we are modeling an enterprise or an organization. Some examples, it can be your school, right? School is a very classic example of an organization. It can be your college or university, right? And can even be a gym. Gym can also be an organization. Like a local gym can also be modeled as an organization. But if there is there are different branches of gym and it is scalable, then also we can consider it an organization. And like the company. So there are different types of things. By company, I mean some specific name of the company, like Google or something like this. So an organization have different components. For example, if you pick school, and we are picking some examples from the college a lot of time in our week 2 discussion and week 3 discussion. For example, we use this entity a lot of time, students, right? When we were learning about tables and we were solving some questions using some examples, we were using a table called students a lot of time. So what is this student? This is an entity set. There are lot of entities and we are using it. For example, we are using courses. So a lot of courses are offered by your college, by your university, right? In different departments. Departments can also be an entity in itself because there are a lot of departments, right? There can also be an entity called uh, instructors. There can also be an entity professors. For example, in our BS degree, we are the students. The course that you are studying, for example, DBMS, can come under this set courses. And we are in data science department, so it comes under the departments. And we have some instructors assigned to us for different courses and some professors that are recording the lectures and providing to us, right? So there are different entities. I'm just taking a few out of them. So you can see that there are a lot of entities, and the entity themselves are not defining the whole meaning of the whole organization. The second thing is the relationship between these entities, right? That is as important as the existence of these entities. For example, a student can take many courses, or he or she can take only one course. What are the rules? Like in the current term, how many courses are allowed to be taken? So they all comes under the relationship criteria. What is the relationship, right? So it is important for us to understand, if we are trying to understand an enterprise, an organization, the whole flow and whole structure of an organization, then this model, entity relationship model, comes naturally to us, because it provides us a way to define these entities and the relationship between them. Okay, so model in itself is not something like an skill or something practical that you are going to code or write, but it is a uh, design that you are creating. For example, if I come and if I ask you that I want to create a website for BS in data science degree, or let's say IIT Madras is introducing a new degree, an online degree. I come to you and I ask you that I want you to design the database of this degree. Can you do that? So this designing process will be simplified by this model. So is it clear why model is helpful? How it is helpful to model, to design a database, right? The designing of the database, the management of that database, as we learned, will be done by something like a relational database management system using SQL that we learned. But how you design it, the answer to that will be given by this modeling of our database. Okay, so there are different terms, just like when we were learning relational database management system, we learned different terms, right? We learned what are attributes and how those attributes can be considered as columns of a table. Then we learned what are rows, what are instances, right? So in the same way, we are going to define some terms for model also. So let's first understand what is an entity, right? Because a lot of you can have confusion about the difference between entity and entity set, relationship, relationship set. So let's understand what is an entity. And I'm not going to write a definition, I'm just going to give you examples. So when we talk about this table, students, so a student, a single student, it can be, let's say, Ram or Salim or anyone, right? So out of all the students present in my organization, in my school, in my college, if I just pick a single student, this student can have different attributes. No debate on that. This student, according to our organization rules, it can have, this student can have roll number, name, gender, age, marks, and so on. But when I pick those that data of this student, when I pick that row, that instance itself is an entity. So for example, if I have 15 students in my college, all 15 students are 15 different entities. Okay, in the same way, it can be a course, it can be DBMS, can be PDSA, can be something about um, a physics course, right? Doesn't matter. But a course, in the same way, an instructor, right? For example, Manideepa ma'am, right? So according to the terms that you are familiar with, an instance is an entity. Simple. Okay, an instance is an entity. Got it? Then comes entity set. What is a set of these entities? And it is very simple. Just like we said that a single student is an entity, I will just say whole collection of students is an entity set. Okay. Entity have a definition, a schema, just like I said, an ID, a name, and these type of things. Now, according to that schema, whatever is being defined in your organization, for example, according to the student schema, if I have 15 different students, then the collection of those 15 students is an entity set. Got it? And in the same way, whole collection of uh, courses, and you can generalize it with different things like instructors, professors, right? Now, second thing is relationship. This is important. A relationship is an association between two different entities. And when I call this different, I mean that their schema is different. In simple word, the first one is an student, sorry, a student, but the second one is not a student. Second one can be an instructor or a course, right? So association between two different entities is a relationship between them. And in simple words, you can just generalize it by saying that if a student had taken 4 courses, then this student have a relationship with course. And there are types of relationship, different types of relationship based on the cardinalities. So based on cardinality, there are 4 types of relationships. The first one is one to one. The second one is one to many. The third one is many to one. This is subjective. Maybe they both can be same because the first one is showing that left one is having one and right one is having many, and the third one is just opposite of that. So you can also define them in the same way just by swapping the left entity to the right one. And the last one is many to many. So when I say that a single student can be associated with multiple courses, so which type of relationship I am talking about?
One to many. One to many.
One to many, right? So this is a single student, and a single student is associated with multiple courses, right? So this is one to many relationship because from the left hand side, I am having only one student. That means only one student is associated with this relationship. But this relationship is going far with different entities of same schema, same set. That's why it is one to many. But can I say that this DBMS is having association with different students? Now, what will you say? Now tell me, is it again one to many?
Yes, one to many.
Sir.
So what do you mean by it? Can you say, like, is it a many to many relationship? No?
Hello, sir.
Yes.
Sir, your voice is breaking.
Yeah, I just asked the question and I'm just waiting for your answer. I just asked you, a student can have association with many students. Sorry, a student can have association with many courses, and a course can have association with many students. So you were saying that it is one to many relationship. But my question is it really one to many relationship or is it many to many relationship?
Sir, it's a many to many.
Many to many.
Too many, sir.
Yep, it is many to many relationship because it is evident. But I'm not saying that in all situations wherever you are creating your schema, whenever you are designing your database, you are forced to make it many to many relationship. It is logical to make it many to many, but the entire decision is in your hand because you are the designer of your database. Currently, when we are learning ER model, the purpose of learning ER model is to actually learn database designing, because before actually going and writing the SQL, database designer go and first design their database. That's why ER model is useful, and that's why we are learning it. So a logical choice as a database designer is to create it as many to many relationship. So a logical thing that I will do, before doing that logical thing,
So here how we can say this one many to many?
because a student can have association with many courses. It is logical, right? A student can take many courses, right?
Yes, sir.
And in the same way, this is called a relationship, and let's call this relationship enrollment. A student is getting enrolled in multiple courses. Now, if you pick the same relationship and put it the another way, can a single course be taken by multiple students? And the answer will naturally come yes, right? It's, it's like a course should be taken by multiple students. It is not especially created for only a single student, Salim, Ram, Sita, Radha, and Puneet, and anyone else should be able to take this course, right? Whoever is eligible, but we are making things simple. So you just have to ask, whenever you are designing the database, you should ask this question in both way. When you are defining a relationship, you should think from both sides and ask yourself, is it logical or not? And if it is logical, then of course you will allow it. And because one student is getting enrolled with multiple students, then it is many from the courses side. And here, because one course is getting enrolled with multiple students, so it is many from this side. It is many to many, not many to one. Got it?
Yes,
Sir,
Now
but in
comes,
second condition, we are talking about only one course, DBMS, right?
Yeah, we are generalizing it. We can also talk about the
So
PDS
how can we say it many in only for DBMS?
because the many is from the student side, because DBMS can be taken by many students. That's why it's many.
Okay, means we are referencing from the first relationship also, right?
Right.
Okay, okay, sir.
So what is a relationship set? So if I define this enrollment relationship, it will come something like this. Let's say I have a table. In this table, I have students, and this is the roll number of the student and the name of the student. And I have two students. Then there is one more table. In this table, I have course ID and course name. First course is DBMS, and the second course is PDSA. Let's say Salim took DBMS and PDSA both. So I need one more table that will store roll number and CID both, right? So for example, if I am showing the relationship that Salim is having association with DBMS and PDSA, then it will be something like this: 1 comma 1 and 1 comma 2. Make sense? Then student 2, Ram, took only DBMS this term. So the relationship will be 2 comma 1. Ram is getting related to DBMS. So second roll number associated with first CID. Got it? Now look closely this table. This one is getting repeated here. This one is coming many times. Am I right? And if you focus on the right hand side, the course entries, course IDs are also coming multiple times, right?
Yes, sir.
So what does that mean? This is the meaning of our many to many relationship. Student is getting same student repeating multiple times. That means for different courses, single student is coming. So this time, same student can take multiple courses. And if you see from the right hand side, same course ID for different students. That means same course can be taken by multiple students. So this is the indicator of many to many relationship. And whole set, this whole set, this whole collection of these three entries is called the relationship set. That's why I first drawn the table. Make this definition easier. Relationship set is nothing but collection of relationship between two entity sets. So this is the set of students entities. You can see the set of two students, right? This is the set of two courses. So this is also an entity set, and this is a relationship set. So whenever you see a table and you want to generalize your knowledge of relational database management system to ER model, you can say that this row is an entity. This row is also an entity. All these four rows, this row, this row, this row, and this row, all four of them are entities. This row is a relationship. This row is also a relationship. This row is also a relationship. And this whole collection of these two students is an entity set. And this collection of these two courses is also an entity set. And this collection of these these three rows is a relationship set. Clear?
So once again, could you repeat?
Okay. So see, whenever you see a table, you can say that every single row of students or courses, every single row of them can be called an entity. Okay. Every single row can be called an entity. But this relationship set that you created, this table is explicitly created just to show the relationship between these two. So these rows are relationships, not entities, right? Because this is not original value. This is borrowed from here. So that's why it is not an entity. This is a relationship. And in the same way, when you see the whole collection of students, they are the sets. The, the collection of entities are entity set. And the collection of a relationship is a relationship set. As simple as that. Nothing complex in that. Okay.
Yes, sir.
Great. So now we truly understand the meaning of uh, these different things, right? That comes again and again in an ER model. Now let's understand attributes and its types. Attributes, you already know what is an attribute, right? For example, in this table, in this entity set, roll number and name, both of them are attributes, right? So in the same way, attributes we already know, but we are going to see its types. So let's first understand the difference between simple and composite attributes. Okay. Let's first understand simple attributes. What are the simple attributes? So you see, simple attributes are those type of attributes that are atomic. You cannot you cannot divide it into multiple meaningful uh, attributes, or I would say sub attributes. For example, let's take a very simple example. If I take my name, or let's take Raj Thakur. Okay, this is a name. Now let's say I am storing this name in a table like this. The first attribute is first name, second attribute is last name. So now you tell me, is it reasonable to break Raj into further multiple parts? Will it be meaningful to do?
No, sir.
No, sir.
No, it is not, right? Because Raj itself is atomic. If you break it, then you are destroying the information. You are destroying the data, right? Same for the last name. They are atomic. If you break them, you are corrupting them. So these type of attributes are simple attributes. But when we talk about composite attributes, they are, as the name suggests, those type of attributes that contains multiple information, multiple sub attributes inside them, and you can divide them further. Okay, so whatever I had written here in this line, the opposite of that, if you change this can't with can, then the definition of composite attribute will be formed. For example, if I again take Raj Thakur, and this time I design my database in such a way that instead of dividing Raj Thakur into first name and last name, I am just storing this into a single attribute called full name. Now, can I divide these values further?
Yes, sir.
And different names are there, but because they are full names, I can logically break them. I can use this space. I can check if the left hand side value is there, right hand side value is there, and if it is there, I can call the left side first name, and I can call this right side last name, right? I can break it, and this division will be meaningful, right? So this meaningful word is very important. It should be meaningful. Otherwise, I could also break Raj. But when I would be breaking Raj, that would not be meaningful. That would be meaningless. But here, if I break Raj Thakur into two parts, Raj and Thakur, then both of them will still be meaningful in themselves. So these type of attributes, those that are able to be divided into further sub attributes, are called composite attributes. So this is the difference between simple and composite attribute. Okay. Now the next distinction is between single valued and multiple valued attributes. So you see, it is again very simple to distinct. Uh, Single valued, again, whatever we are used to, something like roll number, something like your name, something like your gender. They can be only one, right? You can have only single value in them. For example, roll number, you cannot have multiple roll numbers in the same college, right? So if you are enrolled in multiple colleges, then that's a different story. For example, some students are doing this BS degree with one more degree, for example, like BTech degree. So I'm not talking about those cases. I'm talking about only a single enterprise, single organization. So in the same degree, you cannot have multiple roll numbers, right? So this roll number can contain only single value. In the same way, you cannot have multiple names. Your name can be very, very long, but it is only a single name, right? You can have a nickname. You can have some people calling you with different names, but officially, according to the organization rules, it is logical that you would use only a single name, right? So we are not talking about the edge cases. We are talking about what is logical. In the same way, when you are talking about your gender or your age, you will put only one value inside them, right? So these type of attributes are called single valued attributes. But when we talk about multi-valued attributes, then the multi-valued attributes can be something like a phone number. You can have multiple phone numbers, right? So these type of attributes where you can have multiple values are multi-valued attributes. Okay. Sounds reasonable?
Yes.
Yes, sir.
Now comes domain, and I think you already know it. We were uh, learning it at the end of week 1, week 3. Domains, types, and domains, right? Domain are just allowed values for an attribute. For example, if I say that my full name will be string, then what does that mean? It can only take a string, right? It cannot take uh, an integer directly. It should follow the convention of a string, right? So this is the meaning of domain, just like we understood in the form of types in SQL. Now you see, we were learning entity sets above. Entity sets. For example, when we picked a student, we had roll number, we had name, and let's add some more attributes. Okay. Now, when you want to show the primary key of your entity set is just like a table. Okay. So just like we define the schema of a table, we can also define the schema of an entity set. So this students is an entity set according to ER model, and it is representing a set of all students, right? So when you want to show the primary key in ER model, you do it by underlining it. So when I am underlining roll number, what does it convey? It is conveying that I have an entity set called students. In this students entity set, I have roll number, name, gender, and age, and out of them, the primary key is roll number. Okay. So this is how you determine or show the representation of an entity set. Got it? Now comes a very important part, and I think this is very important. Okay, cardinality is done. I'm talking about the types of entity sets. There are two types of entity sets. First one is strong entity set, and the second one is a weak entity set. You see, the definition is also very simple. If a primary key exists for your entity set, just like our students example, if a primary key exists, then the entity set is strong. And when a primary key doesn't exist for your entity set, then your entity set is weak. The definition is very simple. If a primary key exists for your entity set, then it is strong. If a primary key doesn't exist for your entity set, it is weak. This will be understood if the definition of a primary key is clear in your mind. And I think I explained it in very detailed way. So you can ask me the doubt on primary key. Otherwise, you will not understand the distinction between them. Right. Do you understand what is a primary key properly?
Yes, sir.
Primary key is an attribute or a set of attributes that uniquely identify each row or each entity. If there are 15 entities, in our example 15 students, then my roll number is giving a unique identity to all 15 entities, all 15 students. That's why it is a primary key, right? But there are some situations where your entity set is created uh, in such a way that you are unable to find a primary key for it. Okay, you tried by combining different attributes in your entity set, but still there are some duplicates. So one example of weak entity set would look something like this. Let's say there is a weak entity set called apartment. Okay, and in this apartment you have the door number and you have the floor. I'm taking this example from your slides themselves, so you can relate with that. So let's say this is door number and this is floor, and door number is not guaranteed to be always unique for different floors. Two different door numbers, like two different floors, can have same door number. For example, if we are on third floor, the door number, there are multiple door numbers there. For example, 1, 2, and 3. And there may also be a case where there can be one more same door number with same floor. Why? Because of a poor management of your hotel. You see, when we design a database, we need to consider all different edge cases, and this is one of that edge case. The management is poor or was poor in the past, and that poor management in the past, these type of things are occurring, and you cannot do anything about it because this information is nothing but a fact. If in a hotel, in a single floor, there are two doors and their door number is same, cannot um, deny it, right? You have to store that data as it is because this is a fact. If you don't store it that way, then you are denying a real world fact. Are you understanding why weak entity sets exist? Otherwise, you would just ask that why are we storing these weak entity sets? So this is one practical scenario. We deal with these weak entity sets because they represent the real world situation. They are the facts and we cannot ignore the facts. That's why. So what is the way to distinguish these two rows? Because this is a serious problem, right? This is representing the real world, but this is data. When you physically enter that floor and see those two rooms, two rooms, these two rooms have same door number, but because you are a human, you have eyes, you can still distinguish between them. You can say, okay, this room is different and this room is different. They have the same door number. This is a management mistake, but because I have a brain, I am a human, I can distinguish between them. They are two different rooms. But can our database management system distinguish between them just by seeing this data? Yes or no?
No, sir.
No, because it is seeing the data. It is not seeing the room. It is seeing data, and in this data, only 1 comma 3 is written 2 times. So how will it distinguish? That's why there are some techniques to deal with weak entity sets. So you see, for weak entity sets, primary key doesn't exist, but a discriminator exists. Discriminator is just like a primary key, but it is weak. For example, this door number is a discriminator. And just like I said, you use underline to show primary key. In the same way, when you want to show discriminator, you again use underline, but dotted underline. So whenever you see dotted underline, first thing you will understand it is a weak entity set. Second thing, you will understand it is a discriminator. Okay, discriminator is just like a primary key, but just like primary key guarantees that it will always give you unique, discriminator doesn't guarantee. Discriminator just says that in most of the situations I will give you unique values, but I am not guaranteeing that every single time I will give you unique value. For example, if you see door number, it is most of the time giving you different values. This is 1, this is 2, this is 3, but it is not guaranteeing. That's why there are duplicates here and here. Okay, discriminator is just like a weak version of a key. Got it? So what do you do in these type of situations? Because discriminator alone is not enough. It is not giving you the solution of this problem that I described, 1 comma 3 coming 2 times. So how to deal with this problem? So you see, what do we do in these type of situations? We say that, and this is a rule, that when you don't have a strong entity set, then a simulated primary key of a weak entity set can be, first of all, its own discriminator, and you combine it with primary key of strong entity set. What do we understand by it? Let's say this door number and this door number, both of them are for floor 3rd, but there is a hidden information that this door number and this floor was from different building, let's say building A, and this door number 1 of floor 3 is from a different building, let's say building B. But this information is not given to you. This information is stored in a different entity set called building. And this entity set is not weak. This entity set is strong. So you have building number in this, and the building name, and the address of the building. Okay, this entity set is strong. So whenever you face these type of situations, you will define the primary key of apartment as the combination of its own discriminator. What is the discriminator? Door number, plus the primary key of a strong entity set that can be related to it. So apartment can be related to building. So we can combine door number with the primary key of strong entity set building, which is B number, right? The primary key of building is B number. So we will combine door number with building. And when we do that, when we combine B number and door number, Now you can easily distinguish between these two, 1 comma 3 and 1 comma 3. But now, because they have different building numbers, it will be something like this: 1 comma 1 and 2 comma 1. Now this building number is helping you to distinguish these two rows. This 1 comma 3 and this 1 comma 3 will be considered different because of this building number. In simple words, we are taking the help of a strong entity set to define uniqueness in a weak entity set. So please remember this fact. Sometimes it is also asked in exams. A weak entity set cannot exist by itself. I am also writing it here. A weak entity set cannot logically exist by itself. It needs a strong entity set to uniquely identify its each entity. And by entity you can mean, it can be mean that every single row. So I'm always translating the terms of ER model to the terms of relational model. Okay, so a weak entity set cannot exist by itself. It always needs a strong entity set with it to uniquely identify its every single row, every single entity. Got it? And we saw a practical example on what situations a weak entity set may be useful, but it needs a strong entity set. Okay, so whenever you see these dotted lines, you can understand that this entity set is weak, and this dotted attribute, dotted underlined attribute, is a discriminator.
So can you repeat the last two lines, what you said?
This dotted conversation that I have.
Yes, sir, here.
Yeah, so whenever someone gives you something like this, for example, if someone comes and give me this courses, and inside it there is an ID, there is a name, and some more attributes, but they are dotted, underlined. They are not fully underlined. They are underlined by this dotted line. Then you can consider that it is a weak entity set. Okay, and this ID comma name is a discriminator. Okay,
Yes, sir. So this ID is from another table that we have taken?
no, this ID is in the same entity set.
Okay, sir. Okay, sir.
Currently we were just talking about the terms in ER model. I think when we will talk about the ER diagram, these terms that I had introduced in front of you, they will become very clear with the diagrams. So first of all, let's understand. Let's start the ER diagram, and we will discuss all those terms that we were introducing one by one. Let's understand the ER diagram. So first of all, we learned what is an entity, right? And we learned what is an entity set. So in a diagram, this is how you will define an entity set. This is how in ER diagram you define an entity set. You use a rectangle, you write the name of your entity set, then here you define the name of your attributes, and you can see this underline. What is the meaning of this underline?
The primary key.
Primary key,
It's
right?
primary.
And then if you want to show the relationship set, then it will be shown something like this. Between instructor and student, there is a relationship called advisor. Then it will be shown something like this. You have instructor, you have a student, and this diamond shape is a relationship set, and this is the name of this relationship set. Okay, and let's say relationship set have their own attributes. It can also be possible, for example, when I was giving you the example, here it went. Yeah, this example. So this was students and entity set, this was courses entity set, and this was a relationship set that we were calling enrollment, right? So in this entity set, I had only roll number, the primary key of students, and CID, the primary key of courses. But I am not limited to this only. If I want, I can have one more attribute other than these two, and I can call this attribute date. Why? Maybe this date will be helpful to account when this relationship is established. For example, this student is related to this course. That means this student took this course. But I want to also understand when this student took this course, when this relationship is established. For that, I can have one custom attribute called date. So this date can be something like 7 July. So what this date is saying, that student 1, Salim, took DBMS on 7 July. Got it? So we can have custom attributes in our relationship set. So if you want to show these custom attributes, you can show them in this way. Okay, you can see nothing is changed. Just above this diamond, you see we are not determining ID and this ID. Relationship must have the primary key of both the sides. So we don't have to say that explicitly by using the dotted line or anything. But if you are determining a custom attribute, just like this date or some other attributes, then you need to show that in your diagram using this dotted line. Okay.
So why it is a dotted line actually? Why not non-dotted?
Just a choice of a diagram.
Okay. Okay.
Now let's understand the relationship, right? I was saying that there are 4 types of relationship according to the cardinalities, according to the association of number of associations. So the first one is one-to-one, right? So one-to-one relationship is shown like this. Can you spot the difference from the above diagram? There are two arrows, right? So this arrow is determining or saying that only one instructor is participating at a time in this advisor relationship. Only one instructor is participating at a time, and this arrow is saying that one student only one student is participating in this advisor relationship. In simple words, when you see the arrow, then it means one. If you don't see the arrow, it means many. And it will be very clear with the remaining diagrams. You see one to many between instructor and student. It is this one. And you can clearly spot that the arrow is there on the instructor side. So this arrow is showing one. When there is no arrow, it is showing many. Okay. Then comes the many to one and many to many. So I will just quickly paste them. You can, till now, you can just assume how they will look. I think you have the required knowledge. So this is many to one. So you can clearly spot where is the arrow and where is not, to understand how it is many to one. And in many to many, there is no arrow at all on both the sides. Something like this. Okay. Understood how to find out after seeing the diagram? Can you tell me which type of relationship is there just by seeing the diagram? You can, right?
Yes, sir.
Yeah. So this is the cardinality. But I want you to think about a very important thing about relationship. Let's say in my database, there are three instructors. Instructor 1, instructor 2, and instructor 3. And in my student table or entity set, I have three students, S1, S2, S3, and that's it. In my advisor relationship, I1, let's say this is one-to-one relationship, okay? I1 is associated with S1. That means I1 is advising or guiding student 1. Instructor 2 is guiding student 2. That's it. This is the scenario. Okay. So what is happening here? Which rows are left and which rows are not participating in this relationship from instructors and students? Which rows are not participating? Can you tell me?
I3,
I3
I3,
and S3, right?
S3.
So you see, there is not a hard-coded rule that all instructors are required to participate in this relationship, or all students must participate in this relationship. Nobody is saying that, right? There is no hard-coded rule that all students should be present in the advisor relationship, or all instructors should be participated in this advisor relationship. So this is called, the scenario that I gave you here is called partial participation. What do we call that? Partial participation. Okay. And if you do full participation, for example, if I take this instructor's entity again here, and if I take this student entity again, let me just draw that. Or you already have that, so I don't have to draw that again. I can just draw this relationship. And this time I1 is associated to, let's say, S2, I2 is associated to S3, and I3 is associated to S1. So this time, what is different? This time all instructors are participating. Okay. So from the instructor side, we will say there is a full participation. And from the student side also, because all students are participating in this relationship, what do I mean by participation? All students' entries are present in this relationship, right? At least once. So this type of participation is called full participation. Okay. And how do you show that? How do you show that in your ER diagram? So when you want to show the partial participation, if you see this, there is a double line here, right? First of all, just tell me what type of relationship it is. One to many or many to one? It's many to many, right? There is no arrow, not this side and not also on this side. So what type of relationship it is? Many to many, no doubt. But there is a difference, right? On the left hand side, there is a single line. On the right hand side, there are two lines. So you see, whenever there are two lines, there is a, this is the meaning of total participation. And whenever there is a single line, this is the meaning of partial participation. Got it? So what am I saying with this diagram? I am saying instructor and student are associated with a many to many relationship, and students, all the students are guaranteed to be present in this advisor relationship. But all instructors are not guaranteed to be present in this advisor relationship. Only some of them, maybe all of them, but there is a maybe here. There is no guarantee here. But here, there is a total participation, means if there are 15 students, all those 15 student IDs should be, or I would say, must be present at least once in this advisor relationship. Got it? These simple lines are having a big meaning in themselves. One is giving you guarantee and one is not giving you guarantee. Is it clear? Great. So you see, the ER diagrams that we study are not invented by only a single person and are being just used in single way. There are many ways to create an ER diagram, and what we saw just now is just one way to create ER diagram. There is also one more way to show the relationship. So There are different ways, of course, because of in this course we will stick with this way that we understood. But just to mention, in maybe in on Google or somewhere else, if you see something like this, then you should be able to understand the meaning of it, how ER diagram is determined here. So you see, this is one more way to show the cardinality of the relationship. So this is 0, means the minimum number of rows, and this is the maximum number of rows possible. This is the minimum number of rows possible, and this is the maximum number of rows possible. This is for instructor, and this is for student. So you see, this way of writing is very powerful because it is handling cardinalities and it is also handling this participation. Let's understand how. What this minimum is saying? It is saying minimum 0 rows can participate in advisor. So it means this number means that at minimum we don't have a constraint that there will be full participation. This row, this 0 is telling me that an instructor can participate in advisor or it cannot. This 0 minimum threshold is giving me the permission to not participate. But if you see here, this minimum is 1. So what does this 1 mean? This 1 means that there should be at least one student participating in a single relationship with instructor. So for example, if there are 3 rows, then in every single row of this advisor, there should be at least one student participating in this advisor relationship. If there are 3 students, 1, 2, 3, all 3 of them will go inside. Let's understand this maximum. Till now, we understood that this minimum is essentially just distinguishing between partial and total. In simple words, if I be more simple, this 0 means simply partial participation, and this 1 means simply full participation. Okay, let's be very simple here. What does this star means? Star means as many as possible. So this star is just telling me many, as much as you want. But here maximum threshold is only 1. So at most, one student can participate to in a relationship. Okay, so this is just giving me the type of cardinality. The cardinality here is many to 1, because at max I can have as many instructors as I want in this relationship, but here at max I can have only one student in a relationship. Yes, Patel.
Sir, uh, I I do not understand how you distinguish this is partially or full participation.
Okay, so you're confused about how this 0 and this 1 is
No, sir.
essentially getting converted to.
Oh, no, sir. Whenever when you speak, no, then my concentration are not there. That's why. Sorry, sir. But
No, what is the doubt? I'm trying to ask that.
no,
Like,
that time I do not able to hear that time. That's why I say.
okay,
You say
so
zero means only participation 0, and when you speak one, you say up as a 1, and
yeah,
star means up to all.
yes,
But I don't, but not understand what is partial
yeah.
participation
Let's
and full.
let's do that again. It's completely fine. Don't worry about it. So see, just like I said, these two numbers, out of them, the first number is the minimum threshold. At minimum, how many instructors you want to participate. This is the max. So at maximum, at most, how many instructor you want to participate in this relationship. Okay. In the same way here, this is showing at minimum, at least, how many students you want to participate in this advisor relationship. And again, this is the maximum number. At most, how many students you want to be participated in this advisor relationship. So let's understand it practically by example. This 0 is showing you, by the way, this number that is given to you, 1.1, this is being applied to every single row in your student one by one. It doesn't mean that it is being applied to the whole set. It is being applied to every single row. So for example, if I have students S1, S2, and S3. So this 1.1 condition is being applied to all three of them. And in the same way, if I have three instructors, I1, I2, and I3, then this 0 dot dot star condition is being applied to every single row separately. Why did I mention it? Why it is important? Let's understand. So let's start with this left hand side. So at minimum, how many, like what is the minimum threshold? 0, right? When the minimum threshold is 0, what does that mean? I1 can participate or not. I1 can participate in this relationship. Let's say this is instructor ID and this is student ID. So I1 can participate 0 times, at least 0 times in this relationship. So maybe the relationship can be something like this. So this is only the minimum threshold. At maximum, it is going up to star. So this I1 can participate, let's say, with S1. This I1 can participate, let's say, with S2. This I1 can participate at, let's say, with S3. Because the maximum threshold is star. So this I1 can come multiple times, right? But the minimum is 0. That means if I want, I can totally avoid the participation of I3. I can ignore that. It is tolerant. So the thing that we are understanding, I know it is complex, but the thing that we understood by it is everything is our choice. When we talk about the 0 to star, that means everything is up to us. Nobody is restricting us to a certain threshold. At minimum, we have 0. At maximum, we have infinity. So what is the meaning of 0 to infinity? It means no limitation at all, right? So, for example, if someone is bringing so many sweets in front of you, and they are saying at least 0, at most infinity. What does that mean? They are just saying eat as many sweets as you want. Nobody is stopping you. And if you don't want to eat, that's also fine. So what they are saying, the 0 means if you don't want to participate, it's okay. The star is saying you can eat as many as you want. Now is it easy to understand? This 0 is saying if you don't want to participate, if you don't want to eat the sweet, it's fine. This star is saying you can eat as many as you want. As
Sir,
many
I have
sweets as
a,
yes.
clarification. See, you have written the table, no? That last is I2 S1. But if you see the right hand side condition,
Yep.
it is maximum allowed is 1. So
Yes.
here for S1 there are two instructors. So that fails the condition, no?
That fails the okay, okay. Whatever is written here, right? According to that,
Yes.
you are,
Yeah.
yeah. According to that, it is not allowed. Actually, I was
Okay.
focusing on the left hand side when I
Fine.
drawn this.
Okay, fine.
Yeah. So
So, so I have a question.
yes, yes, please.
Like between student and the advisor, the
Yep.
minimum is one. So that means whenever one
Yeah.
is written, that means it's that total participation. Because the one minimum
Yeah.
minimum one should be there. That means it signifies that there has to be total participation.
Right. So why I'm saying that, the main thing is this one dot dot one condition is being applied to every single row. Understanding this is the essence. So this S1 have this minimum one threshold. This S2 also have this minimum one threshold, and this S3 also have this minimum one threshold. So let's forget this maximum for now. Just focus on the minimum. Let's say the maximum is star, as many as you want. So your relationship, your advisor should or must contain S1, S2, S3 as at least once, right? So S1 can be associated with I1, S2 can be associated with I2, S3 can be associated with I3. But because this is a star, at maximum, if you want, I can again have S1 with, let's say, I2, right? Because maximum is a star. But this is showing the minimum. At least S1, S2, S3 should come once. So this is why we quickly understand that it is total participation. Okay, but in our relationship, it was one. The maximum was also one. So with that, we understood that a student will exactly come only once. So this is not allowed. If S1 is connected with I1, S1 again cannot be related with I2. It can have only one occurrence, either with I1, either with I2, either with I3. Got it? So this was just for explanation. You don't have to do this hassle every single time. You can directly see this, and in short form, if you see 0 here, what will you understand? This is partial participation. When you see 1 here, what will you understand? This is
Total participation.
total participation. When you see star here, what will you understand? There is a many here.
Maximum.
Yeah. When you see 1 here, there is a 1 here. So it is many to one relationship. If you see star here, you will say there is a many here. That means it is many to many relationship. Simple. Got it? So maybe in exam sometimes this notation can come. That's why I took the hassle. Like I took this much time to explain this. Okay. So when we were learning about attributes, I think I forgot to mention one special type of attribute, and that is derived attribute. So we discussed simple attribute, we discussed composite attribute, we discussed single valued attributes and multi-valued attributes. There is one more type called derived attributes. What are derived attributes? Derived attributes are all such attributes that, as the name suggests, are derived. They are not stored in the database, but you are using some function to derive them. For example, very classic example of it will be age. Now, I am asking you, I am creating a student data set, okay? A student table or a student entity set. Will it be a wise decision to store the age of the student?
No, sir, because it's dynamic.
Age is dynamic. Every single second, the age is changing. So the reasonable approach is to store date of birth, right? So whenever you have these type of entries which are always dynamic, you should not store them in your database because they are always changing. You will store age 15, but after 2 years, it will be 17. But in your database, it is still 15. So this is the problem. That's why you should store something static. And whenever you need the age of the student, you can run a function and you can find the difference between now and the DOB, and you can directly find out the age, right? So these type of attributes that are always derived instead of getting stored are called derived attributes. Now let's see the representation of all of them: simple, composite, and single valued, multi-valued, and derived attributes. Let's see the representation of all of them in ER diagram. Simple attribute is of course simple, and single valued is also a simple type of attribute. So there will not be special representation for them, but there will be special representation for composite attributes, multi-valued attributes, and derived attributes. So the representation is this one. Yep. So see, ID is a normal attribute, a simple attribute. So we are just writing it just like we were writing ID here, name here, salary here. So all simple attributes are just written simply. But when you have a composite attribute, what is a composite attribute? That can be broken into further meaningful sub attributes. Then you show these broken parts like this. For example, if you pick the name can be broken into three parts. So you will determine three parts like this in ER diagram: first name, middle initial, and last name. So these all three are the sub attributes of our main attribute name. So this name is a composite attribute. Okay, whenever you see a representation like this, where you are also showing the parts of it, then it simply means that you are showing a composite attribute. Got it? Same for the address. Address have street, city, state, zip. So this address is a composite attribute. And inside it, this street also is a composite attribute that is having a street number, street name, and APT number. Got it? Then comes the phone number. You can see these curly braces. Whenever you see curly braces on an attribute in your ER diagram, this is a clear indication of multi-valued attributes. Those attributes that contains multiple values together. Okay. For example, I have two phone numbers. I will store them using comma. So this is first phone number. This is second phone number. I am storing them using a comma between them in a single attribute, like phone number. So this is a multi-valued attribute which is storing multiple values. Okay. Date of birth, simple attribute. What is the meaning of age? It is having these parentheses just like a function. So these type of indication always says that it is a derived attribute. Got it? After seeing ER diagram, can you distinguish which attribute is simple, which attribute is composite, which is multi-valued, which is derived. Great. Now we also learned weak entity sets, right? So it is also important to understand how you show the weak entity set.
Sir, which is the single valued attribute, sir, in that table?
Single valued are just all these simple attributes. They are also single valued. Okay. So just like I said, you don't have a spatial representation for simple attributes or single valued attributes. You have a spatial representation for these composite, multi-valued, and derived attributes.
So this date of birth, it has three components, no? So is it composite or
No, no,
single?
no. These are not components. These are just the way. This is a
Okay,
single name that you wrote like this. Just like you can see the first name is written like this.
okay.
Like this is a delimiter. Whatever is coming. Just like a space. This is just a
No, no,
limit
not
delimiter.
that I'm asking. In date of birth, we have a day, month, and year, no?
Oh, you are asking about that. Yeah.
That,
So according to this design, date of birth is considered as a simple attribute.
okay,
So just like I said, you are the database designer and you have the job to design the data. And these ER diagrams just represents that design. So this design is showing that date of birth is considered a single attribute.
okay,
Okay, so it will be according to the design. If you want to design it that way, then you will have to show it in a different way.
okay. Under that date,
Yeah,
month, and year. Okay,
yeah. Just like you show the name in the same way.
okay.
This is how you show the weak entity set. Now you will ask me, you want to show me weak entity set, but why you are showing me two sets? You should only show me this section, right? Why are you showing me this course? But if you remember what I said, then you will easily understand. When we were talking about weak entity set, I made a line. I said a weak entity set cannot logically exist by itself. It always needs a relationship. It always needs to maintain a relationship with strong entity set to exist. So that's why when we are defining a weak entity set, we are defining it in that way. So you see, to show the weak entity set, we use double lined rectangle. This is the weak entity set. This is the strong entity set. And we are using this relationship sec course. Can you tell me what is the discriminator here?
Sir, all thing like sec, ID, semester, and year because you do dot line uh,
So
below
are you
this.
saying that we have three discriminators?
Yes, sir, because you do line. That's why I say.
Yeah. So it doesn't mean that we have three discriminators. It means that the set of all three is a discriminator. Okay.
Okay,
It doesn't mean that we have three discriminators. It means the set of all these three is a single discriminator. And when you maintain this weak relationship with course, what did I say? We will use its own discriminator plus primary key of strong entity set. And this combination will become the primary key of weak entity set. So keeping this formula in mind, can you tell me what is the primary key of section now?
Course ID plus set of these three.
Yeah, course ID.
Plus set of these three, like sec underscore ID, semester, and year.
So this combination is the primary key of this weak entity set. Primary key of section is course ID, comma section ID, comma semester, comma year. Okay. So these type of questions can also be asked in the exam. Most of the time they don't come. In the past, in maybe 2022 or something, I saw this type of question. It is not coming in the recent terms, but still I'm just discussing it. Be prepared if it will be there. If someone asks you what is the primary key of a weak entity set, it is nothing but a combination of the primary key of the strong entity set plus the discriminator of weak entity set. So this whole set, which is containing all these attributes, is the primary key of the weak entity set. Got it? Now just give me 1 minute. Yeah, one important thing is I told you how you will define the entity sets, something like this. You will give the name, and in the parentheses, you will give all the attributes, and you will underline the primary. This is how you define the entity set, right? When you want to define the weak entity set, you do that something like this. You give the name, which is section here, and here you give uh, all the attributes. First of all, you give the primary key of the strong entity set, course ID. Then you give all the discriminators, section ID, semester, year. So section ID, semester, year. And after that you give all other attributes that are not discriminator. For example, if there is one more attribute here called term, that is not a discriminator, after that you will give it. So how I am representing a weak entity set? I am naming it. I am opening the parenthesis. First thing, I am giving the primary key of strong entity set. Then I am giving all the attributes that are discriminators, right? Then I am giving all those attributes from section that are not the discriminator. Got it? After that, what will you do? You will underline all of this. Why? Because this whole thing is your new primary key of weak entity set. Got it? So if in exams or in any question you see this representation of weak entity sets, you can easily interpret the meaning of it, why it is shown like this. What is the meaning of this underline? Got it? There's nothing complex. It's just what we said, primary key of section. We are just underlining all four of them. That's it. Because as I said, we underline the primary key when we represent an entity set. And when you want to represent a relationship set, let's say you want to represent uh, this advisor relationship, okay? How will you do that? You will take the advisor. In advisor, you have the instructor ID and you have the student ID. You will underline both of them, and this will become your uh, representation of relationship set. Got it? I will say there are much more things that are given in your slides. I will definitely recommend you to go and read your slides thoroughly. It is really important, and I always recommend you this for every single week. Always refer to your slides or the lectures, whatever way you prefer, the reading or the watching. But it is really important. Actually, I left one more thing.
So for quiz one, if we revise the slides, it is enough, or we have to watch that videos in the portal?
The lectures are just discussing the content that is present in the slides. So I would say just revising from the slides is more than enough.
Better. Okay.
It
Okay.
is subjective. So for those who are not very good in reading, so it is really subjective question, right? So I cannot give you an absolute answer, but it is
Okay.
just my opinion that reading
Okay.
the slides will be enough.
So,
So
what is
I,
your course handle? So, if I have a question, I can tag you.
yeah, it is 0986 without spaces.
Thank you, sir.
So I forgot one important thing. What about the self relationship? Like if I want to, if I have this situation, um uh, yeah, I have met one, I have met two. Can I take met two without completing med one?
No, sir.
No, sir,
Why?
No, sir.
Why?
because MAD 2 is a
Because it's
MAD
prerequisite.
1 is prerequisite of MAD 2.
Med one is prerequisite of
Prerequisite.
med two. So the situation here is this is course entity. This is also course entity, and the relationship between them is prerequisite. Am I right? Right.
Yes, sir.
So you see in DBMS in ER diagram, how do we show these type of relationships? Now we are going to understand that. So we show it something like this, and this will be kind of weird for you to understand, but we use something called rules. You see what we are doing? We have this single entity, and this is the relationship called prerequisite. We are opening one line from this side, and we are again coming back to the same entity because this is the same entity set, right? You are creating a relationship in same entity set from one course to other. So let's say the course ID for med 2 is, for med 1 it is 1, and for mat 2 it is 2. So what will be the relationship? This is the course ID, current course ID, and this is the prerequisite course ID. Okay, so what will be the values? If the course ID is 2, what will be the prerequisite? 1. Correct? Because course ID 2, mat 2 have a prerequisite 1, mat 1. So this will be the relationship, right? Because it is a same entity set, the attribute name will also be same, right? But we don't want to be confused by writing course ID 2 times. That's why we create roles, and these roles are just for the primary key. So the role of first primary key, we are giving course ID as it is, but the second role we are giving as prereq ID. Okay, so it is as simple as this diagram. Just we are using shortcuts. So please see this diagram very carefully, and you will realize it is more simple than it looks. Right? This is just a spatial representation when you want to describe the relationship in the same entity set, just like the scenario that we are discussing. Got it? Okay, so let's combine this information that we collected.
Can you repeat it?
I didn't describe anything. I was just saying, see this diagram and relate it with your casual diagram like this one. In this diagram, you had the relationship between two different entities, instructor and student. And here you have the relationship with the same entity set 2 times. So we are just renaming our ID 2 times just to distinguish between them and determine the relationship. That course ID is different, prerequisite ID is different. To make this relationship possible, we are doing that. Otherwise, you would have something like this: course ID, comma course ID. It will be way more confusing, right? You will not able to understand which one is prerequisite and which one is not. Correct? So when you combine this knowledge and you design your whole database, it will look something like this. So you can see this is your database. This is the ER diagram of university database. Okay, this is how you designed your whole university database, and in real world also you will be designing the databases, and maybe you will use ER diagrams to show the picture form of that. So can you see how helpful ER diagram is when you are designing your database? You didn't write the code yet, you didn't write the SQL yet, but you are designing, you are logically thinking, planning. This is the phase of planning, and ER diagram is helpful to plan the design of the database. So in every phase, you are understanding something. We have instructor, we have a department, and between them, there is a relationship called instructor underscore depth. So it is just a random name, but there is a relationship between instructor and department, and this relationship is many to one. That means many instructors can be associated with one department, but many departments cannot be associated with one instructor. That's why it is many to one relationship. Every instructor is participating in this relationship, but it is not mandatory that every single department will participate in this relationship. Just by a single glance, you can understand the design of your database. Correct? It is really helpful, right? When you are working with 10 different engineers, your senior created this ER diagram and given you. You can directly see and understand, okay, this is how senior designed the database, and now I will write the SQL query for that. So the main goal of this session was to give you the intuition why ER diagram is helpful. Did you get the intuition? In what situations it will be helpful, and when multiple engineers are working together, how it can be helpful? Great. Okay. There are some more things that are left. Let's quickly cover them. You see, currently we were seeing only binary relationships. What do I mean by binary relationship? The relationship between only two entity sets. So this is a relationship between course and section, only two entity sets, right? But it is not a hard-coded rule that there will be only binary relationships. Most of the time there will be binary relationship that you will see, but it is not something like guarantee that this will be only binary relationship. You can have uh, ternary relationship also, like the relationship between more than two entity sets. Those type of relationship also exist, right? So let me find one example for that. Yeah, this diagram is explaining two concepts that I want to discuss. So you can see what type of relationship this proj guide is. If you see it, what type of relationship it is. How many entity sets are participating in this relationship?
So this is a ternary relationship.
This is a ternary relationship, right? Instructor, project, and student. All three entity sets are participating in this relationship. So this is a ternary relationship. You can even have some relationships where maybe four entity sets are participating. So it can be scaled. There's no limit to it. But most of the time, you will see binary relationship between uh, two entity sets. And sometimes you will observe this type of example. So this is the first thing. This is a non-binary relationship, ternary relationship. Ternary means three. So relationship between three entity sets. One, two, three. Right? Second concept that I want to discuss here is aggregation. You see what you can do? You can treat this whole relationship as a single entity set. This whole relationship, whatever is present in this project guide, you can treat that as a single entity, and you can further make relationships. So you can see what we are doing. We are creating this rectangle, and by this rectangle we are saying that whatever is coming out of this relationship, just treat that output as a single entity and make one more relation with evaluations, and that relationship is eval4. Got it? This thing is called aggregation. we didn't do anything. Okay, I'm not saying that we changed something or we did something significant. We just did a very simple thing. We created a diagram to show that this ternary relationship is being treated as an entity, and we are using this to create further relationships. We just said something as simple as that. Okay, this is called aggregation. You just have to know it. You don't have to execute something or write something for it. You just have to know it. Now, final thing on this session, and this will be the final part of week 4. This is called specialization. Give me 1 minute, please. Yep. So you see, there are two types of specializations. First one is overlapping, and the second one is disjoint. Let's understand them one by one. The example of overlapping and the representation of it is this. Whenever you see this type of diagram where there are two entities and the arrows are coming above to a single entity, they are pointing out to a single entity. Multiple entities are pointing out. There can also be a third entity pointing out to this. Okay, so when multiple entities are pointing out to a single entity, that type of specialization is overlapping. And what is this type of specialization saying? It is saying that faculty is a type of person, student is a type of person, just that. Okay, but when we are talking about disjoint specialization, it is written like this, and it is saying slightly different thing. You see what it is saying? It is saying undergrad is a part of student. Postgrad student is a part of student. It is saying the type, it is saying the part. So you can also see from the diagram is breaking into two parts. The single line came here and it got divided into two parts. But here, something different happened. Two entities just pointed, but nothing got divided, right? So this is the difference between disjoint and overlapping. Overlapping is showing a type, just a type. Student is a type of person, faculty is a type of person, but none of them is saying that person is divided into these two parts. Person is a very big class. Student, this one is saying that we had a student and we made some parts of it. First part is called undergrad, second part is called postgrad. But both of them are partial. I didn't discuss about this partial thing. What is the meaning of partial? I talked about overlapping, this type of specialization, and I talked about disjoint, this type of specialization, but both of them are partial. What do I mean by partial? It means a person is much more than faculty and student. If tomorrow a doctor comes, they are also a person, right? If tomorrow a PhD student comes, they are also a part of the student, right? That's why both of them are partial according to our database design. You see, we are not talking about real world. When we talk about database design, we don't talk about what is true in real world. We talk about what is true according to our database. Okay. So according to our database, we have to determine this separately. And how do we do that? If we want to show the full relationship, sorry, complete specialization, we do it something like this. And it is really very simple. We just use this dotted line and we just write total in our ER diagram. When we do that, it means we are now ourselves, we are saying that part have only two subparts, purchase part, manufactured part. Other than that, there is no possible other part that can come into future. We have only two parts. That's it. So when we explicitly say total, we are neglecting any future possibility. But when we don't say total, it means maybe in future there will be a new type that is currently not present. Maybe in future there will be one new entity that can be a person, right? This is the difference between partial and complete specialization. Is it clear? If you have any doubts, you can ask me. According to the agenda, we covered ER model, we covered ER diagram. So in summary, we are done with week 4. Of course, just like I said, I will recommend you to go and read the slides to get some deep information about ER model and what is a model, what is actually a database design. So these type of things are being discussed in the slides, but they are too abstract and will require a lot of time to explain. That's why I excluded them from these sessions. You can always ask them as doubts in the future sessions. We will cover them. But for now, we are done with week 4. Okay, so your syllabus till quiz 1 is now covered. You can collect this whole information in your mind. In this in these notes, I think everything's covered. The week 1 outline, the week 2 and 3 outline, and week 4 outline also, and the topics of it. So with that, I think you should start collecting the knowledge that you covered till now, and you should start solving the questions, the problems on them. Okay. So when will be practice and summary sessions. So you see, in these two TA sessions, I mainly cover the theory. So in Sunday sessions, Apurva help you guys with the practice. So if you also want me to help you with the practical stuff, then also I can do that. You can just let me know whatever you want in these sessions. I will just cover that. Okay, it's not like hard coded thing. From the next session, next week, we can start solving the PYQs and we can start covering the remaining things that are not yet done. Okay, then we are ending this session here. I hope you will practice a lot. I will again refer that those HTML notes that we are making. In my opinion, they are really good, and we are actively working on them. So you can refer them. Week 4 notes are created by me. So I mentioned every single thing that we learned today in those notes in detail also. So you can also refer them to have just the summary of what we are learning. Okay, then